The use of old electrical panels as junction boxes is generally not considered a common or acceptable practice in most areas. It's typically viewed as a makeshift solution that may compromise the safety and reliability of the electrical system. There are several reasons why using old panels as junction boxes is discouraged. Firstly, safety hazards. Old electrical panels may not meet current safety standards, and using them as junction boxes can create electrical hazards. They may not have proper grounding or overcurrent protection, which can increase the risk of electrical fires or shocks. Secondly, circuit overloading. Old panels may not have the capacity to handle the additional circuits being added from the new panel. Overloading circuits can cause overheating, damage to wires, or even electrical fires. Thirdly, code violations. In many jurisdictions, using old panels as junction boxes violates electrical codes. Electrical codes are designed to ensure the safety and reliability of electrical installations, and using old panels as junction boxes may not comply with these codes. Fourthly, unprofessional appearance. Old panels used as junction boxes can look unsightly and unprofessional, which can be a concern for homeowners and inspectors. Instead of using old panels as junction boxes, it is recommended to follow proper electrical practices. One such practice is installing a new junction box that meets current electrical codes. Another is using properly sized wires and overcurrent protection devices. Also, ensure that all circuits are properly grounded and labeled. And lastly, having the electrical work inspected by a qualified electrician to ensure it is safe and compliant with codes. While it is possible that one may not have encountered the use of old panels as junction boxes in one's area, it is not a widely accepted practice in the industry. It's important to always follow proper electrical codes and standards to ensure the safety and reliability of the electrical system. When dealing with electrical systems, always prioritize safety and adherence to established codes and standards. Electrical codes are put in place for a reason, and deviating from them can have serious consequences. Proper grounding is essential for preventing electrical shocks and fires. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect against overloading and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to wiring and equipment. When installing a new junction box, make sure it is properly sized for the number of wires and connections it will contain. The box should be made of a non-combustible material and should be securely mounted. Use the correct size and type of wire for the circuits being installed. The wire size should be appropriate for the amperage of the circuit, and the wire type should be suitable for the environment in which it will be installed. Label all circuits clearly so that they can be easily identified. This will help prevent confusion and make it easier to troubleshoot problems in the future. Have all electrical work inspected by a qualified electrician to ensure that it is safe and compliant with codes. An electrician has the knowledge and experience to identify potential hazards and ensure that the electrical system is installed correctly. Remember, electricity can be dangerous, and it is important to take all necessary precautions when working with electrical systems. If one is not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Also, it is important to consider local regulations. Electrical codes and regulations can vary from one jurisdiction to another. It is important to check with the local authorities to determine the specific requirements for electrical installations in one's area. Ignoring local regulations can result in fines or other penalties. When working with electrical panels, it is crucial to follow lockout/tagout procedures to prevent accidental energization of the circuit. Lockout/tagout involves disconnecting the power source and securing it with a lock and tag to prevent someone from accidentally turning it on while work is being performed. Electrical panels should be properly maintained to ensure that they are in good working condition. This includes inspecting the panel for signs of damage or corrosion, tightening loose connections, and replacing any damaged components. If one encounters any problems with electrical panels, such as flickering lights, tripping circuit breakers, or unusual smells, it is important to have the panel inspected by a qualified electrician. These problems can indicate underlying issues that need to be addressed to prevent more serious problems. It's also important to be aware of the limitations of electrical panels. Electrical panels are designed to handle a certain amount of load, and exceeding that load can cause the panel to overheat or fail. When adding new circuits to an electrical panel, it is important to calculate the load and make sure that the panel has enough capacity to handle it. Consider energy efficiency. When installing new electrical equipment or appliances, choose energy-efficient models to reduce energy consumption and lower utility bills. Energy-efficient products use less electricity to perform the same task, which can save money and reduce the strain on the electrical system. Surge protection is also a good idea to protect electronic equipment from voltage spikes. Surge protectors divert excess voltage away from electronic devices, preventing damage from lightning strikes or other electrical surges. Whole-house surge protectors can be installed at the electrical panel to protect all of the circuits in the home. Consider arc fault circuit interrupters, abbreviated as AFCIs, for added protection against electrical fires. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. AFCIs are required in many areas for circuits that serve bedrooms and other living areas. Ground fault circuit interrupters, abbreviated as GFCIs, are essential for protecting against electrical shocks in wet locations. GFCIs are designed to detect ground faults, which occur when electricity flows through an unintended path, such as through a person's body. GFCIs are required in bathrooms, kitchens, and other areas where water is present. When working with aluminum wiring, use the proper connectors and techniques to prevent corrosion. Aluminum wiring is more susceptible to corrosion than copper wiring, and corrosion can lead to loose connections and overheating. Use connectors that are specifically designed for use with aluminum wiring, and apply an antioxidant compound to the connections to prevent corrosion. Also, consider the age of the electrical system. Older electrical systems may not be up to current standards and may need to be upgraded. Older wiring may be brittle or damaged, and older electrical panels may not have enough capacity to handle the demands of modern appliances and electronics. If the electrical system is more than 25 years old, it may be time to have it inspected by a qualified electrician. During an electrical inspection, the electrician will check the wiring, electrical panel, outlets, and other components to identify any potential hazards or code violations. The electrician can then recommend any necessary repairs or upgrades to bring the electrical system up to current standards. When making electrical repairs, always use quality materials and follow the manufacturer's instructions. Using cheap or substandard materials can compromise the safety and reliability of the electrical system. Follow the manufacturer's instructions carefully to ensure that the repairs are done correctly. Electrical work should always be performed by a qualified electrician, but it is helpful to have a basic understanding of electrical concepts. Knowing how electricity works can help one understand the importance of safety precautions and make informed decisions about electrical repairs and upgrades. Learning about electrical concepts can be as simple as reading books, watching videos, or taking a course. Also consider the importance of regular electrical maintenance. Regular maintenance can help prevent problems and extend the life of the electrical system. Maintenance tasks include inspecting the wiring, electrical panel, outlets, and other components for signs of damage or wear. It is also important to test the GFCIs regularly to make sure they are working properly. Consider the future electrical needs. When planning electrical upgrades, think about future electrical needs. Will one be adding new appliances or electronics in the future? Will one be expanding the home or remodeling the kitchen? Planning for future electrical needs can help one avoid the need for additional upgrades later on. When choosing an electrician, get multiple quotes and check references. It is important to choose a qualified and experienced electrician who is licensed and insured. Get quotes from several electricians and compare their prices and services. Check references to make sure that the electrician has a good reputation. Also verify the electrician's licensing and insurance to ensure that they are qualified to do the work. a permit might be needed. In many jurisdictions, a permit is required for electrical work. Check with the local authorities to determine whether a permit is required for the electrical work one is planning to do. Obtaining a permit ensures that the work will be inspected by a qualified inspector to make sure it is safe and compliant with codes. One of the most basic electrical concepts is voltage. Voltage is the electrical potential difference between 2 points in a circuit. It is the force that drives electric current through a circuit. Voltage is measured in volts. Common voltage levels in residential wiring are 120 volts and 240 volts. Another important electrical concept is current. Current is the flow of electric charge through a circuit. It is measured in amperes, often shortened to amps. The amount of current that flows through a circuit depends on the voltage and the resistance of the circuit. The relationship between voltage, current, and resistance is described by Ohm's law, which states that voltage equals current times resistance. Resistance is the opposition to the flow of electric current in a circuit. It is measured in ohms. All materials have some resistance to the flow of electric current. Materials with low resistance are called conductors, while materials with high resistance are called insulators. Conductors, such as copper and aluminum, are used to carry electric current in circuits. Insulators, such as rubber and plastic, are used to prevent electric current from flowing where it is not wanted. Power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. The power in a circuit is equal to the voltage times the current. Electrical appliances and devices are rated in watts to indicate how much power they consume. Understanding these basic electrical concepts can help one make informed decisions about electrical repairs and upgrades. When working with electricity, always follow safety precautions and consult with a qualified electrician if one has any questions or concerns. Furthermore, consider the environmental impact of electrical choices. Choose energy-efficient appliances and lighting to reduce energy consumption and lower the carbon footprint. Dispose of old electrical equipment and batteries properly to prevent pollution. By making environmentally conscious choices, one can help protect the planet and conserve resources. Stay informed about the latest electrical codes and technologies. Electrical codes are constantly evolving to reflect new safety standards and technological advancements. Stay up to date on the latest codes and technologies to ensure that the electrical system is safe and efficient. Read trade publications, attend seminars, and consult with qualified electricians to stay informed. Finally, remember that electricity is a powerful and potentially dangerous force. Always treat electricity with respect and follow safety precautions when working with electrical systems. If one is not comfortable working with electricity, it is best to hire a qualified electrician to do the work. By following these guidelines, one can ensure that the electrical system is safe, reliable, and efficient. The National Electrical Code, often abbreviated as NEC, is a widely adopted standard for safe electrical installations. It is important to familiarize oneself with the NEC and follow its guidelines when performing electrical work. The NEC is updated every 3 years, so it is important to stay up to date on the latest edition. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for ensuring the safety and reliability of electrical systems. Many local jurisdictions adopt the NEC as their electrical code, while others modify it to suit their specific needs. Check with the local authorities to determine which version of the NEC is in effect in one's area. The NEC contains numerous tables and figures that provide information on wire sizes, conduit fill, and other electrical parameters. These tables and figures are essential for designing and installing electrical systems that meet the requirements of the NEC. For example, NEC Table 310.15b16 provides ampacity ratings for various types of conductors based on their size and insulation type. This table is used to determine the appropriate wire size for a given circuit based on the expected load. The NEC also specifies requirements for grounding electrical systems. Grounding is essential for preventing electrical shocks and fires. The NEC requires that all electrical systems be grounded to a common grounding electrode system, which typically consists of a ground rod or a metal water pipe. The NEC also contains requirements for overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices are designed to protect against overloading and short circuits. The NEC specifies the maximum size of overcurrent protection devices that can be used for various types of circuits. The NEC also covers the installation of electrical equipment such as lighting fixtures, receptacles, and appliances. The NEC specifies requirements for the location, mounting, and wiring of electrical equipment to ensure that it is installed safely and correctly. The NEC is a complex and comprehensive document, and it is important to consult with a qualified electrician when performing electrical work. An electrician can help one understand the requirements of the NEC and ensure that the electrical system is installed in accordance with code. Furthermore, consider the importance of using the right tools for the job. Using the right tools can make electrical work safer and easier. Invest in quality tools that are designed for electrical work, such as wire strippers, pliers, screwdrivers, and voltage testers. Use insulated tools to protect oneself from electrical shock. When working with electricity, always wear appropriate personal protective equipment, abbreviated as PPE, such as safety glasses and gloves. Safety glasses protect the eyes from flying debris, and gloves protect the hands from electrical shock. Also, be aware of the presence of asbestos in older electrical systems. Asbestos is a hazardous material that was commonly used in electrical wiring and equipment in the past. If one suspects that asbestos is present, it is important to have it tested and removed by a qualified professional. Asbestos can cause serious health problems such as lung cancer and mesothelioma. Consider the importance of energy management systems. Energy management systems can help one monitor and control energy consumption in the home. These systems can provide real-time data on energy usage and allow one to adjust settings to reduce energy consumption. Energy management systems can also be used to control lighting, heating, and cooling systems to optimize energy efficiency. Stay informed about new developments in electrical technology. The electrical industry is constantly evolving, with new technologies being developed all the time. Stay informed about these developments to take advantage of new opportunities to improve the safety and efficiency of electrical systems. For example, smart home technology is becoming increasingly popular, allowing homeowners to control lighting, appliances, and other devices remotely. Be sure to follow the NEC guidelines when installing smart home technology to ensure that it is safe and compliant with codes. Consider the importance of electrical safety training. Electrical safety training can help one learn how to work safely with electricity and avoid electrical hazards. Take a course on electrical safety to learn about common electrical hazards and how to prevent them. Electrical safety training is especially important for those who work in the electrical industry or who perform electrical work as part of their job. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect oneself and others. By following these guidelines and consulting with qualified professionals, one can ensure that the electrical system is safe, reliable, and efficient.